Hi guys, welcome to my live. In this one, I'm basically going to be trying to build myself a Ridge wallet using Fusion 360. And I'm going to begin by creating a credit card. So I'm going to begin with a box and we'll standardize on the normal axis. And I'm just going to draw this box and then type in the details manually. So, I know the height is 0.676 inches high, and I'm going to double check all the details. So it's 3.375 inches wide, double check that again, 3.375 inches. And then it's going to be 2.125 inches. And we probably need to sort these around a bit. So that's the length I typed in there. Inch. There we go. So that seems a little bit high for me. I'm just going to double check that's valid. I need to look up the ISO standard. Sorry, 0.0299 inches. Or 0.76, try that again. 0.76 millimeters. There we go. There we go, that's the size of a credit card. And of course we got the rounded corners on a card as well. So need to find out what that is as well. And with the corners of 0.88 to 3.48. So we'll go for 2.88. So we're going to click on that, and then going to click on these edges. Click on this edge as well. And we're going to click on the fillet tool. And we're going to round that by 2.88. And click on OK. So now we have our mocked up credit card according to the ISO standard 7810 and a bunch of other numbers no one ever cares about. So we're going to have one with like 5 of these. Now I also want to find out how high the embossing in the card is. So what's the maximum height of an embossed credit card? Hey Luna, how's it going? So I don't think you could see me doing an internet search right now, but I'm basically in my browser finding out the ISO standards. Credit card, there we go. Right, typical cards have a traditional card thickness. So embossing is limited to certain card thicknesses, typically cards with a thickness of 20mm to 30mm. Traditional credit card thickness of better embossing. Thicker the better, blah, 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 blah. It's the thickest credit card. Yep, so the thickest it can get is 0.76 thick. I'm assuming that includes the emboss as well. So we should be able to use that model. Either way, I'm going to put a slight. I am using Fusion 360. So now we have my card here, bodies, and we're going to call this dummy card. And I'm going to organize how I want this shaped in my wallet. And I want 5 of these stacked on top of each other. That seems fine to me. So that's 5 cards, 1 wallet, each one about a millimetre separated, which gives about 0.24 millimeters in between the cards. Now we're going to want it in a stacked formation. I'm going to name these cards properly first. That will be 5. And of course this needs to be 1. Just type into Google Fusion 360 for hobby. That's how I found it, to be honest. Or type in Autodesk Fusion 360 Personal, might also get you there. So what I really want to do now is sort of arrange these in the staggered formation I will want when the wallet is popping them out. So if I take this one up here and I move this one, actually I'll do it from the other way. So I do it this way first, and I'm going to take this and move it up. So I kind of want it grabbable. So how far did I move it? 4 millimeters. I'm going to make that 5. And we'll move this one up 10. I just want to select 1, thank you. And cool. Grab that. So this will then move up 10. And we'll select this one as well. And we'll move this up 10. It should be 15. Why don't you try getting code from ChatGPT? It will be a good experiment. Because I hate AI when it comes to coding. I do not see the point in using something that I have to rewrite the code for anyway. It's a bit like asking your mate to give you his homework, only you spend the next 2 hours correcting his homework. Right. So I think the easiest way of doing this would be... I've also tried it, and I've tried it with some simple programs. It works for simple programs. I've tried it for more complex programs, and it falls over miserably. If you want something that will give you Pong, it will just about handle that. If you want something that does something more complicated, then nah, don't bother. Just do it yourself. Stop cheating. Right, so I'm just making a part here. Anyway, I didn't get into coding for someone else to do it for me. There's no fun in that whatsoever. I can write my own functions. I don't need it to write me functions. That's what it comes down to for me. New body. And we'll angle this one. So I'm kind of experimenting here because I'm not quite sure I'm going to make this mechanism work, but we're going to find out. Basically what I want to do is doorstep this. I am making a Ridge wallet. Of course you see the appeal of it. It's doing your work for you. The trouble is I'm coming across a lot of people who will then rely on AI to do their work for them, won't really question what goes in there, and you can get all sorts of nasty things going on. Like code injection. Maybe it's copied the wrong bit of software. Maybe someone's hacked the AI. You're better off writing these things yourself. That way you know exactly what you've put in there. Because honestly, if I was a hacking community right now, the first thing I would do is try and get loads of my malware examples imported into AI, so when hapless coders try to actually generate code, it's going to start repeating their malware stuff. It's only a matter of time before it becomes insecure like everything else. Exactly, you need to audit, but people won't. People will get lazy. They'll go, oh, the AI wrote it for me. It seems to work at a glance. That's good enough. I don't have to do it anymore. I know what people are like. They will do this. And there is no amount of human safeguards. I mean, let's face it. You're doing something as serious as driving a car. You are instructed to pay attention to the road, keep your hands on the wheels. While they were doing the Tesla tests. And when they actually reviewed the footage, people were playing on their phones, they were sleeping, one was lying on the back. It was ridiculous. No, their lives were at risk here, and they were just lazy. And as soon as you give a human being the ability to be lazy, it will be. So don't give it the ability to be lazy. That's my motto anyway. Maybe I'm old-fashioned. I don't mind using it for comments, but again, I will always read those comments through, and more than often than not, I end up rewriting them. I'm too old. I've been around humanity too long. I know what it's like. Give it an AI tool, it will take shortcuts, things will go wrong, and they'll have no one to blame but themselves. So no thank you. I will write my own code, thank you very much. I mean, right now I'm probably screwing up the entire design for this thing, but I'm going to learn more screwing it up than I will if I say AI, make it perfect for me. 0.1. No, I'll give 0.2, that's fine. I want to give it a little bit of immersion. What's my profession? I've got a number of professions, mate. Mostly I'm an e-learning developer. I work a lot with kids. I work with adults. I've seen how they I've seen how they take shortcuts. I've been spending some time writing something to try and detect AI for their homework assignments. It's getting that bad. Let's round that off. I'm going to round this off well. But no, my main job is as an e-learning developer, but I'm also a front-end developer. I may well be training to be a Google Cloud engineer soon. You need to use AI? No, you don't. There are ways of detecting AI without needing AI. Okay, that should be okay. So what I'm going to do now is copy these cards. And okay, then I'm going to select this arm here. It would be interesting to see your implementation without using AI. I guarantee you, once that is written, I won't be giving it away. You'll end up being sold as part of the courseware packages we offer. That's the long-term plan. Right, we're going to now remove if I gave you pseudocode, I might as well give you the actual code. No, I'm not giving you the methodology either. You can work it out yourself. Or, you know, you can ask AI to detect AI. Let's do that, and let's do that. Right. So now let's hide all of these. Yeah, I thought there'd be these gaps. I expected there to be gaps. That's fine. So I'm going to grab all these. I'm going to... See, one of the biggest issues for me regarding AI is I am an old Star Trek fan. And there was this one episode where they all beamed down to a planet and they've got a computer they can't fix. And no one knows how to fix this computer. So they've got to plug themselves into this AI, which then takes control of their bodies so they can fix everything. And it is scarily becoming real. When we start requiring AI to fix AI, for example, how do you know that AI has your best interests at heart? How do you know if someone hasn't altered that AI? Yeah, you got to put a lot of trust into this, and I don't. AI is not a black box. It's a neural network. It's a very complicated neural network that's hard for a human being to follow, but it's still a neural network, and that means it is trained on the data it's given. You give it the wrong kind of data with the wrong kind of intention, and you will have a neural AI you can't control. And if people get too lazy and rely on AI too much, it's going to spell trouble. It is. I mean, right now the world is being run by algorithms. Everything you see, everything you watch, all controlled by some algorithm somewhere. It's not a good state to be in. I didn't want to roll that, did I? Yeah, it's not going to work anyway. For example, right now, which country is it? There's a country where someone is actually running a politician by AI. Can't remember the name of it. Can't remember which country it's in. I need to look that up. And that's a dangerous precedent to sell. MP is AI. Oh, Tory MP reads out AI-generated speech in Commons first. See, it's already getting into our politics. Yeah, it's not good. It's not a good situation to be in. There's some things we shouldn't give up as a human race. It's limited right now. The trouble is you add innovation and propagation, and just look up the Jupiter brain. Just go look up the Jupiter brain. It's a science fiction concept, but then AI was a science fiction concept itself once. Right, so I think what I'm going to do now is shave a bit off here. Traditional computer power has been increasing massively, mate. There's no such thing as traditional computer power. There's just evolving computer power. Compared to what I had as a kid, which was a BBC Master with 16 megahertz, I'm sitting here literally making a 3D model in virtualized software. This was impossible when I was a kid. Now it's commonplace. I don't even have to pay for the software. It's gotten that far now. Oh, I've been chopping bits off there. That's not good. Didn't want to do that. Right, let's try that again. And I'm going to turn these off. I'm going to bring that up. See, now you're training your AI to go and look at virtual worlds and build them for you. Next thing you know, you'll be powering a machine race of alien beings who are using you as batteries. Okay, maybe a bit of a silly example. But when you end up in the Matrix, it's your fault, mate. I am building... Right, I'm just going to build a box here to cut that off. No, I'm not. I am making a Ridge wallet. Probably very clumsily and without the help of AI whatsoever. So we'll see here that I've basically got a stack of credit cards. And I'm just trying to come up with a simple mechanism that will allow me to lever the cards up. So we kind of got that armature now. I'm going to round... no, I tried rounding the corners earlier. It wouldn't work. So that's fine. So I've got the extreme now. Thinking about the design. Yes, I'm going to 3D print it. This is Fusion 360 Personal Edition. So it's free if you want to go download it and play with it. Alright, so basically we've got all the cards here that I want to be ejecting upwards. We got the armature that I've just designed. It's probably a little bit thick, to be honest, but it's fine. I can slim it down later on. My thought on quantum computing, to be honest, I don't understand enough of it to really comment. This is Fusion 360 Personal Edition. Right, so basically this is going to be a lever, so something's going to hook under it, pull it, push it down, and then when you push the cards down, it will go down. That's my general vision right now. If you want to go for computer science, go for computer science. But the thing is, you don't have to go for computer science. You can go online. W3C Schools is a good place to start. Go learn HTML. Start learning how to make a web page. Once you start learning how to make a web page, start learning back-end systems. Go become a Google Cloud engineer, AWS, all that kind of stuff. Learn compute power. Web languages are probably the way things are going right now. We are offloading more and more local processing onto cloud platforms. So that is where the action is going to be. Hello, how's it going? Depends on what you want to get into. If it's high-level programming, it's not just what you want to get into. You've got to look at the market and work out where the market's going, because by the time you train, that's what they'll be looking for. Someone who's trained in the right technologies, and everything is going platform and web these days. So, like I say, AWS, Azure, Google Cloud platforms, these are the kind of things you need. Online education is good enough to get you somewhere. I'm completely self-taught. I have literally no qualifications whatsoever, yet I've written courses for colleges, universities, and schools. So it tells you how much education is necessarily worth if you're willing to go out and learn it yourself. But for that, you need more of an entrepreneurial experience. Someone who's willing to go out and be self-made rather than follow the general crowd. But if you want a 9-to-5 job and you want someone to employ you that way, in the traditional way, then yes, go get a piece of paper and some qualification. It will help you massively. But put some thought into what you want to study, and not only that, but what part of technology you want to start influencing. Nice. No, didn't think that would do what I wanted. We'll try that again. There we go. So what kind of a sharp edge on that one to be hooked under. So basically the idea is something will... actually, it needs to be pushed down, so I need to reverse that. So I'm going to grab this edge here, and I'm going to press it inwards. That's kind of the leverage arm I want. Kind of stuff and skills where the market's going. Yeah, exactly. The thing is, you've got to be thinking, right now, everyone's going after this technology for jobs. what's the technology that people are going to be looking at in 5 years' time? Because by the time you've gone through university and learned these core skills, you will be looking to get into work. And if you've trained to be something that's going out of fashion or no longer in vogue, then you're going to have a harder time getting a job. But the one thing that's probably not going away anyway anytime soon are the web technologies. But the web technologies are also changing, so you need to be careful and just do your research. And also, don't be afraid to pivot. Once you've got to the point where you've got your computer degree and that kind of thing, don't be afraid to go off and learn other languages. You don't need a qualification to go and learn Rust. You don't need a qualification to go learn Python, PHP, or Kotlin, or any of these other languages. You just get on with it. Once you know the basics, you can transport your skills from one thing to another, especially if it's C-based languages. In your opinion, major language is going to be out of fashion. What major language is going to be out of fashion? Java is probably the one that's going out the window. It's still very persistent, but I think it's Java and PHP are probably the ones that are losing traction at this point. It's probably a little bit thick, but that's okay. I'm going to make the other piece now. So what I'm going to do is create the lifting arm. Yes, it's going to be a pull-up lever. No, it's not. It's going to be a push-down lever. I'm pushing it in the wrong place. I want to push down. I may have actually screwed this up a little bit. Hang on. What I need to do now is actually rotate this to the pivot I want it to be at. So we got it here where it's going to lift up the cards. So what I want to do is rotate it. Set pivot. And rotate it. Oh, free move. Okay, fine. Right, let's try that again. I screwed that one up. So let's click on that. Click on this. And set pivot here. And rotate. Nope, that hasn't grabbed it. Why hasn't that grabbed it? Whee! Nothing's rotating. Okay, that was a waste of time. Let's try that again. Click on that body. Click on this. Bodies. Yep. Select. Yep. Set pivot here. Why aren't you rotating? Why aren't you rotating? Fine, try and create a copy. You know what? I'm just going to do this the old-fashioned way. This is what happens when AI doesn't do it for you. Just copy the body, and I will rotate it and replace it that way. So I want that to be more or less flat. So that's going to be in the lifting position. I'm going to eyeball it, and then I'm going to move it. So it's, there we go. So that's a quick and dirty way of pivoting it without actually having a pivot. Okay. So now we can get rid of this first one, and this becomes the lifting arm. Most of the best projects by my teams are done in Net and C++. Yep, they're both popular languages. C# is mainstream now. Yes, it is. Python is indeed taking over, mostly because it's come through the education system and people are just trained in Python now. Personally, I prefer to learn C-based languages because when you know C-based languages, you can move between them, if you know what I mean. If you know C++, you know Java, you know JavaScript, you know any number of C++ based languages is what I'm trying to say. Right, so I need to move these cards back down now into their final resting positions. So you can see where I'm trying to simulate different positions that cars are going to be in, and then I'm taking out chunks of the arm in accordance. So now I'm basically going to do what I did when I first started this, which is duplicate all of these. And then I'm going to hide the original ones. And I'm going to subtract these from the arm itself. So let's take the lifting arm and let's subtract these. Right. So now what I'm going to do is grab these little tabs that have appeared and I'm going to drag these down with an extrude, which will basically subtract it from the material. And now we should have all our credit cards lying nice and parallel against the arm in all directions. That's my theory anyway. And yeah. And there you go. So there's the card arm. Now I may need to round these corners and things, but right now I just want to get some prototypes created and see how that goes. Right, so I'm going to need an arm to push it down. Yeah. So if I create a box, there like that, stretch it over, bring it down, and set it to join. And now we have the lifting part of the arm. I'm going to round off this. Thanks, man. I appreciate it. And thanks for coming by. Create a box here. So basically, this will get pushed down on. Let's show the cards again so I got some reference. It's probably a good idea to save my project at this point. Yeah, I agree. 3D prototyping is really, really good. It's not very good if you actually want to produce anything, but it's fun to make things with. I tend to see it as a new Airfix. Try that again. Extrude to this. Thank you. And extrude to this. Thank you. This is where I probably want to do a sketch. Well, no, actually, first of all, I'm going to take this all the way up there. I'm going to give it a little thing to pull on. And I'm going to round it down using a press pull. So the idea is this goes down, it pushes this arm up, forces the cards up in 5mm intervals. So we don't need this body, but I'll just call this a lifting arm lifted, and that will be disabled, and that will just be lifting arm. So as that gets pushed down, that goes up. I saw F1 teams using 3D printers to make parts. Not surprising. If the part needs to just be used very quickly, it's probably a good way of doing it. So, yeah. You can kind of see the mechanism I'm trying to design here. I think I'm going to use... Yeah. I'm going to try a sketch. Create... sketch. All right. I want something thin that will bend. when it comes into contact. So I don't want this too thick, but I don't want it so thin either that it just breaks. So this is the bit that's going to take the no. Let's try doing this a bit straighter. I don't want any. Yeah, I want it curved. I need it curved. I want it just catching the edge of the card. Yeah, if I give it some more room. So I can make it thicker down here and kind of make it a bit thinner going up. No, I don't like that curve. Yes, this will be a coin version. I'm going to do 2 layers. One for card, one for coins. I may have made that a bit too big, but it should push back. I think I've made it long enough and flexible enough just to push back. So assuming that's the case, that's probably good enough. That will probably take a few more iterations to get right. So I'll get that 3D printed and I'll test it. I think that looks okay. Yeah, that looks decent enough. I think the McLaren 3D parts printed about 9K parts in 2022. Not surprising. The ability to design something on site and get it manufactured in like a day or so is invaluable. And it would be a huge cost-saving measure. Right, so I'm going to now create a box. Right, first of all, actually, what I'm going to do is create the bottom of it. Right, that should be enough room. Evening. 3 mil thickness is fine. No, I can get away with 2. Because I'll be putting a compartment underneath this one as well. Right, I don't want to cut. I want a new body. I don't know if you're seeing this, but your dev comment on your video made me howl. Well, everything is a feature at the end of the day. That's why we have marketers. Right, so I'm going to disable these cards now. Let's double check. That. I need to bring this down a bit. Too much. I just need to shave a bit off. That's probably fine. And lifting. I need to start naming these things properly so I don't forget what they are. This is the lever. Print, test in the wind tile, modify, test again. Yeah, that rapid turnaround, especially when you're no longer having to machine parts, is a lifeblood for projects like that. I'm going to extend this out. So there we've got the first wall. I'm glad you're enjoying it. So what I'm going to do now is make a copy of this. And I'm going to... No, I didn't make a proper copy, did I? Let's cancel. Oh no, I did that one right. Let's leave that one where it was. And lifting arm. I need to duplicate the lifting arm. Okay. Lifting arm. I want to duplicate the lifted lifting arm. And okay. And I'm going to hide these. I want to merge these. And you'll see the reason for my insanity in a moment. Unless it doesn't work, in which case I'll claim that I wasn't going to do it that way anyway. Yeah, so I'm just going to merge these two together as one unit. So join, select, yes, all one, wholly an abomination. That way I should get the full radius all in one point. So now, if I reveal everything else, so body is back, we'll get the lever back in place. Oh yeah, that reminds me, I need to make more room for the lever to go down. So the lever needs to go down about 2 blocks, just call it 2 blocks. So I'll take this. And I'm going to take it down. I'll give some extra space, it doesn't matter. So now I've got enough room for that to be pulled down, which will push that down, which will lift that up. And what I now need to do is create a... I'm going to hide the lever. I'm going to create a box, and I'm going to do it on this plane. Then I'm going to eyeball that, bring it down here, and drag it across. And I'm going to lift that up to the same height as this one. So the same height as that one, thank you. That is now going to be a join object. but I don't want it to join to the lifting arm. And now I'll reveal that again. I'm actually going to take this down to there, and then I'm going to go, this here is now subtracting this. Okay. Go on. Other way around. Right, let's select the right thing. Let's cancel that. That got messed up. Select this one. Cut, select this one. And then OK. So now I've got the groove. That was probably a very roundabout way of doing it. But that was the drop down of the groove. So what I'm now going to do is drop these down as well. There's absolutely no reason. Wrong one. Collect. Do what I want you to, not what I tell you to, because what I tell you to is usually wrong. Extrude down. Okay. Extrude down. Okay. And extrude down. Okay. And I don't want that being caught. So this is going to be grabbed and pulled. Just like that. So now in theory, if I enable the lifting arm, it now has enough momentum to, so it fits in there okay. So what I'm also going to do now is grab this lifting arm again. I'm going to copy, paste it. Okay, and I want to oversize it a little bit. Let's see if the scale works. So scale factor, uniform 0.2. Give it 0.3. I'm actually going to go non-uniform because I don't want this on the Z-axis. I just want it here. So let's try 0.5 and a 0.5. Right, that might be a bit too much. So let's try 0.2, 0.2. I just want to give it a little bit of space around. And then I'm going to take this body, and I'm going to do another subtract of the lifting arm. There we go. So that's made the gap around this a little bit more tolerant. Though there is a little bit here that I'm going to try and I'm making a ridge wallet. Right, let's bring this lever back in. Now that needs to be pressed all the way down, so lifted. Of course I didn't do it for that way, did I? So I need to make sure there's plenty of space down there. think maybe hollowing it out further was a bit of a mistake, so I'm going to cancel that. So now I'm going to take this and I'm going to do the same trick I did earlier, which is rotate it as far as I think it needs to be, then move this, try and match that radius. Then I'm just going to do a subtract. And that way I should get the motion of the arm going down. It's probably a better way of doing this, but I tend to think in old shave bits of metal off mentality, which probably isn't the best way of thinking about it, but it's the only one I know right now. So, yeah, okay, that's fine. So we'll take this body and we're going to do another subtract. I tend to think in Boolean terms, to be honest. There we go. And then lifting arm, lever, there we go. So obviously let's draw a box. Create box. Create it here. Drop it down to here. Give it enough space to here. And lower it to this point. And we'll disable the lever and the lifting arm. And we will click on OK. There may not be enough plastic there, but I'm going to try it this way and see if it works. But we're slowly getting the shape I desire. We are making a ridge wallet. Right, that should give it a bit more rigidity. Right, I need to put a hole in here now. I want to make the pin quite large because that is usually the first thing that breaks when it comes to 3D printing. Anything layered on top of each other tends to be a bit dodgy. Okay. Or I could use a proper screw. I'll stick to this method for the moment. Right, so that's the hole there. Create box. Just going to fill up the hole here. And then I want to put a cylinder. Just move it down a little bit. No, That's too loose. That's probably close enough. Right. And lever. So that gets, this gets pushed down, that goes up, cards go pop. That's probably all the mechanism I need right now. Add a bit of thickness to here. And we're not that far off now, to be honest. Obviously I want something running along here, so I'm going to extrude this up. I want something running along here. So box, create, and we need it sort of here-ish. I'm making a ridge wallet. Drag this up. That looks like it probably works. So as that gets pushed down, this gets pushed back, cards get released, this moves down, moves the cards up. Then when you load the cards back in, this gets pushed down, this pushes that back up, and then this clicks into place. That's the basic idea of what's happening right now. I'm going to raise these surfaces by about 0.2 millimeters, give it a bit of clearance. So 0.2. And then I can create another box and run it along here. And this becomes a top panel, which I will give about a height of 2 millimeters. I will also make this a new body. And then we're going to start thinking about screws. So this is what the overall thing should look like. Cards in there, lever on the side, and I need some screws. So I'm going to pick 3mm screw holes. And so 2.9. Wrong one. Let's try that again. 2.9. That goes just call it 12. Just needs to go all the way through. So there's the first screw hole. I will be using hex nuts as I always do. Okie dokie. And I will then take this off just to make sure everything looks pretty decent. And put a hole there. That looks good to me. Let's see if I can squeeze one in here. Actually, this will be a bit of a weak point. So, top panel, hole. Let's bring that back up. That's probably okay. Yeah, I will do on another prototype. Right now I just want to make sure the mechanism works. And I will round off these corners and do some beautification. I also want to add another layer on the bottom of this one, which will be the coin storage. Because someone said, I hate Ridge wallets, you can't put any coins in them. So I want to put another hollow area with some kind of mechanism to actually stuff money and coins into as well. But yes, you're right. This particular version would absolutely catch on your pockets. But because this is like the very first version, yeah. I have a mate. He has one of these Ridge wallets, and it's got this money clip on the outside. And every time he pulls it out, I just imagine the money falling off the clip, or I imagine someone seeing a big bunch of money attached to this thing and just taking it out of his hands. It's just like, oh. Yeah, I like to conceal my wealth. I want people to think that wallet is there, it looks fat, but it might be full of 1-penny pieces. That's probably giving criminals far too much credit for thinking, but you know what I mean. I don't want a very obvious target that someone then gets the idea that they really want it in their possession quickly. Actually, I can round these. I can round these. Yeah, I can round these quickly. Yeah, there's no reason I can't. Yeah, that's fine. This corner's fine. That corner's fine. That'll do. Yes, no, it won't actually catch on people's pockets. And you never know. The first one I print out might be so perfect I never need to make another one. He says knowing that will never be the case. I will probably go through at least 2 more designs of this. Yeah, well, I hope it does. So I'm going to take one more look at the inside. So we got the lever, we got the springy bit. It's thick enough to push that up, we got that. I want it to be looser because the problems I've had is the parts are just too tight because you get a little bit of expansion sometimes with the filament I'm using. So I wanted to put a little bit of tolerance on there. If I take away the cards, you'll see that it is ridged. So it will go into these grooves when it's actually up. In fact, when it's up, oh, my lifting arm, yeah, lifting arm raised, basically looks like that. We have enough room for it to go there, and it won't go much further. This will be FDM, so I do have to put in a bit of tolerance in this, which is why I'm using screws as well, because those fit together pieces are often a pain in the bum. So this is the base. Got the top part. We just need the lifting arm now. And those are our 4 parts we actually need. Everything else is pretty much dead weight. And that's good to go, to be honest. Just a matter of getting it to the printer now. So that will be the next stage. So I'm going to save this. And I'm going to hide the bits and just export them. Ooh, interesting. That one doesn't have a hole in it. So which one did I make with a hole in it? Never mind, I'll just make another hole. It's fine. So let's get that base back up again. Let's make another hole. Now, I believe I made this 8mm. So we'll bring it down to 6mm to get it centered. Take it up to 7mm. That's pretty good. Take it to 7.5. That should be enough then. Disable the base. Click on OK. Re-enable the base. There we go. I should have enough tolerance there. It's really just to stop it rattling around too much. And it shouldn't do. But I may need to make the tolerances a bit tighter later on. But for this first one, I want to give a little bit more leeway. So, yeah. So I'm just going to export these parts one by one. So, save. Yes. And export. So, trying to decide what to call it now. I'm just going to call it Slim Wallet. So this is Slim Wallet arm. And then we'll have export Slim Wallet lever. And we'll have export Slim Wallet base. And Slim Wallet top panel. panel. So now I'll go into Explorer, and I'll actually have to change my my software then. But so slim wallet base, slim wallet lever. There's slim wallet arm. Great idea. I like that. Works nicely with lever, printed resin. I'm using Ubuntu server on an old laptop to host my website. Good. We should all be reusing old tech. Right, I'm going to flip that over. Then I'm going to add in... Oh yeah, you can't see this part, so I need to actually swap my software over. 1 second. So what I'm going to do now is Fusion 360. I need to change that to another program. Come on. Give me a list of programs, please. Thank you. No, you're not going to cooperate? Fine, we'll just go to desktop mode. I don't care. Display capture, show source, hide this one. And now you'll get the infinite thing of me. Anyway, you can actually see what's going on here. What do you think of the KS Edge 2 that has a Rockwell chip? I've never used it, so I can't really comment on it, sorry. Where is it? Where is it? There it is. As you see, I've got rather a few files I've made over my time. Right. Slim wallet. So there's the arm. Where's the rest of you? You're not going to show? No? Okay, fine. I'll do it manually then. Actually, what am I doing? I just go sort by date modify, can't I? There we go. So we'll have that in there. Did that work? Of course it didn't work. That'll be far too easy. Fine, I'll just copy this folder. File, load file. Slim wallet base. Oh, the base has managed to capture the arm as well, so we've got to redo that one. So where's Fusion? Come back to me, Fusion. Right, we disable that one, we'll have base back. Okay. Why are you in there? You shouldn't be in there. Let's try exporting that again. You want to make an Android Switch emulator with it. Yeah, I kind of want to make what am I calling? A Steam Deck. I want to make a Steam Deck, but I want to get the parts for an old DOS machine, so it ends up being a DOS Steam Deck with very low power hardware, but sort of nice screen and that kind of stuff. But it's a matter of having money. If only TikTok would pay me. Yes, I know it exists. Right, let's go back over to Flash print. File. Load file. And we want... Was it in ThumbPy? Hang on. Of course it's gone. Oh well. Okay, it is ThumbPy. Again, just sort by date modified. I just wish it didn't go to that one. There we go. So base. Thank you for the roses. I appreciate it. So move that one down there. I wonder if I'll be able to fit both on here because they're a bit thick. File, load file, top, Slim Wallet, top panel. Yeah, that's not going to fit. I'll print that one separately. These are the most important pieces to assemble anyway. File, load. File, load, lever. That all looks reasonable at a glance to me. I'll just use the auto layout feature because I'm lazy. Nothing there needs supports. So let's have a look at my settings. I like to whack it up to 270. That seems to give me the best. I'm going to print this on a raft. I'm going to give it some extra shells. And slice. Let's see how that comes out. That looks halfway decent to me. And how long is that going to take? 3 hours and 33 minutes. That's not bad, actually. Obviously, there's another part to print on this, so it'll probably be about 5 hours by the time I'm finished. But that's not bad. I'll start that printing going. And that's about it, really. I've achieved my basic goal. I've just got to start this printing, go to sleep, wake up, and see if it works. So check my TikTok channel. I will be producing a video on this being printed and maybe an assembly. See if it works. You can see how it goes dramatically wrong and how I have to redesign things, which is what always happens with these things. But that's also half the fun of it. So thank you everyone for joining me on my live this evening. I hope you've enjoyed our discussions and watching me build this. I hope it's inspired you to give this a go. This is Fusion 360, so really useful software. If you want to watch this video, it's going to go straight on to my YouTube channel, which is youtube.com/@CKenthusiast. And yeah, that's it. So thank you everyone for joining me on tonight's live, and I hope you all have a fantastic evening.